Hello friends, welcome to Electrical Design Engineering YouTube channel. You can watch my videos in your language. Follow the steps to set your language. Step 1. Click the gear icon. Step 2. Select audio track. Step 3. Select your language. You may contact me for industrial design substation layout power system studies on +9 1700 647 4688, call or WhatsApp.
Hello friends, welcome to Electrical Design Engineering YouTube channel. This is our lecture number 6 of our free course DIgSILENT PowerFactory. In this lecture we will see how to model different types of electrical loads. We have discussed in the lecture number 5 different types of electrical loads, and in this lecture we will see how we model these loads. I want to recap you the previous lecture that different types of electrical loads are constant impedance load, where the P is directly proportional to V square. Actually, these loads are depending on the voltage, how they behave, depend voltage dependency of the loads. And constant current load, in which the P is directly proportional to V, and constant power load in which VI, that is product, is constant, that means P remains the constant, and ZIP load, that is where Z is 30% and I is 20% and P is the 50%. This is the composite load of all these three loads. This percentage is given as per the IEEE. If you want to know more in detail what are the loads which are constant impedance loads, constant current loads, and constant power loads, then you can see watch my lecture number 5. Now, how you can model these loads in the DIgSILENT PowerFactory? This is the question: how you can model, how you can define these loads in the DIgSILENT PowerFactory. When you open the DIgSILENT PowerFactory, and when you start load modeling, you will get this screen, that is the voltage dependency of P, that is the active power, and the voltage dependency of Q, that is the reactive power. For that you have to remember, 1 minute, for that you have to remember this formula. This is the formula: P is equal to A P V A exponential of AP. So you have to define these loads in terms of coefficients AP, BP, and CP, and coefficient exponents EAPV, EBP, ECP, and similarly for the reactive power you have to define the coefficients and the exponentials. This is the constant. Here it is, you can see the coefficient AP is 1 and exponential EAP is 2. Similarly here AQ is 1, EAQ is 2. This is the constant impedance load defined here. I will show all these the loads how you can define and what are the values of exponential and the coefficients for different types of loads. For the constant impedance load, AP is equal to 1 and EAP is equal to 2, and similarly the AQ is equal to 1 and BQ is EAQ is equal to 2. Others are 0, that is BP is equal to 0, CP is equal to 0, EPB is equal to 0 for this constant impedance load. Similarly for constant current load, BP is equal to 1, EBP is equal to 1, and BQ is equal to 1 and EBQ is equal to 1. And for constant power load, CP is equal to 1, ECP is equal to 0. Similarly for CQ is equal to 1 and ECQ is equal to 0. For ZIP, the AP is equal to 0.3, BP is equal to 0.2, and CP is equal to 0.5. The exponentials will remain the same. For the Z, the exponential is 2, that is the EAPB is equal to 2, and for constant current for I, that is EBP is equal to 1, and for this power, that ECP is equal to 0, but only the coefficients will change. Now we will go to the screen, we will go to the DIgSILENT screen, and we will see there how you can define these loads. You have noted down these values for different types of the loads, and the values of coefficients and exponentials. This is our DIgSILENT PowerFactory. screen, we have defined here different types of load. That is the constant, this is the constant Z, and this is the constant I load, and this is the constant P load, that is constant power, constant current, and constant impedance load. First of all, we will double click on this and we will see the coefficients, values of coefficients and exponents for that. This is the values of coefficients and exponents for that, which I have discussed early, which I have told you early. You can note down these things and click OK. And second thing is that for a constant current, you can see what are the, you can see for BP is equal to 1, EBP is equal to 1, and BQ is equal to 1, EBQ is equal to 1. Similarly, for constant power load, you can see this is the coefficients and exponential values, and click on. And for ZIP with same percentage, that is 30, 20, and 50 percentage, you can see 20, 30, and 50, 20, 30, and 50. Okay. Now how you can get the screen when you define the load? I will take this load and click here, and I will double click here. Then here is the type, you can select the type. In the type you will select the new project type, and then general load, and then load flow, and this is the coefficients, where you have to define the load in terms of coefficients and the exponents. Okay, we will delete it back. Yes, now we will see the first of all the ratings of these loads. You can see that all the loads are 1 megawatt and power factor is 0.8 considered. You can see also here the all the loads are 1 megawatt and power factor is 0.8. Okay, we can click on the execute, but we have to consider the voltage dependency. First, we will not consider the voltage dependency. You can see all the loads will behave as a constant power load. They will take the power 1 megawatt, and you can see one execute. See, this P is 1 megawatt, P is 1 megawatt, P is 1 megawatt. All the loads behave as a constant power loads. Now, because we have not considered the voltage dependency here, now we can go and click here, and then I will see. Now we will consider the voltage dependency of the loads. The voltage dependency of, when we consider the voltage dependency of the loads, when we execute this, you can see their power will be different as per the voltage executed. You can see the power here is now point, you can see it is 0.964 megawatt, and it is 0.982 megawatt, and it is constant power load, and it is 1 megawatt, and it is ZIP load, and it is 0.987 megawatt. Similarly, their reactive power is also changing as per the voltage. Thank you.